All right, so this will be your first lesson on exponential functions. So what we're going to talk about today is just exponential functions in general, and then we're going to work on some graphing of these exponential functions. So first thing I want to point out is an exponential function has a x in the exponent. So we've been working with polynomials, rational functions, which have x's being raised to a power. Like 2 or 3 or 4. But in this case, it's an exponential because the x is now in the exponent. Exponentials have a base. So this is going to be the base of the exponential. It is what number is being raised to the power. So for example, you might have a base like 2 or 3 or 4, or you could have a fraction like 1/2. One thing that you won't see for your base is you won't see the base being equal to 1. And this is why. If you take 1 and you raise it to a power of x and you plug in values for x, what's going to happen? Well, 1 to the power of 1 is 1. 1 to the power of 2 is 1. 1 to the power of 3 is 1. So what's happening is nothing interesting, right? Your graph isn't going anywhere because 1 to any power is always 1. Another thing is that base has to be greater than 0. It cannot be a negative base. And here's why. Think about a negative number. Let's just go with -2. If you have -2 and you raise it to the power of 1, you're going to have -2 as your answer. If you take -2 and you raise it to the power of 2, then you're going to have a +4. And if you have -2 and raise it to a power of 3, you'll be at -8. So you'll go from -2 to +4 to -8. And then it would just keep bouncing back and forth, +16, -32. It's just going to bounce up and down between positives and negatives. And that is not going to make an exponential function. That's actually just kind of like a different scenario in terms of it's like a series of numbers that just alternate back and forth between positive, negative, positive, negative. So that doesn't fit in with our exponential functions. So the base can never be negative. This a value is just some number in the front, just a constant in the front being multiplied. There could also be some adding or subtracting happening here as well. And all that's going to do is just kind of shift your exponential function different directions. But the main thing here is b can't be 1 because anything to the first, or 1 to any power is just equal to 1, which is super boring. And it can't be negative because with a negative number being raised to a power, it would just jump back and forth between positive, negative, positive, negative, positive, negative. All right, so here is our first exponential function, y equals 2 to the x. And so this is what we call the most basic exponential function because 2 is kind of the most basic number you can work with because you can't work with 1. And so this is just kind of like the parent function essentially here, like the most basic exponential out there. And so we're going to start here and we're going to make a table. We're going to use our table to plot our points. So the first number that you want to plug in is you want to plug in 0 because anything to the 0 power, and I don't know if you want to write this down, anything to the power of 0 is always equal to 1. That is a rule of exponents from Algebra 1. Anything to the 0 power equals 1. And then from there, you're going to want to do a couple positive numbers. So positive 1, this would be 2 to the power of 1, which is equal to 2. And then power of 2, this would be 2 to the power of 2, which is equal to 4. And you can see what's happening is that we're multiplying by 2 every time, right? Times by 2, times by 2. And that's because the base is 2. Now we're going to talk about what happens when we get into the negative. So we're going to put in -1. So here's what's going to happen. You're going to have 2 to the negative first power. And there is a rule out there that says if you have anything to a negative power, you can rewrite that as 1 over that thing, but to a positive power. That is the negative rule of exponents. You can change negative exponents to positive exponents and vice versa by putting them in the denominator of fractions. So if we have 2 to the negative first, this is going to be 1 over 2 to the first power, which is equal to 1 over 2, or a half. The same thing will happen when we put in -2. 2 to the negative second power is 1 over 2 to the second power, which would be 1 over 4. Notice that pattern still continues. You can times by 2, times by 2, times by 2, times by 2. Or if you think about this way, divide by 2, divide by 2, divide by 2, divide by 2. Those numbers have a pattern going on there. All right, so what we're going to do is we're going to go ahead and plot these. I like to start at 0, 1, and then 1, 2, 2, 4. And then for the decimals, you just have to get close, right? So -1, a half, and then a fourth. And here is your curve. This is going to curve up, and this one is going to curve and run along the x-axis there. So it's just going to get closer and closer and closer to the x-axis. By the way, hopefully that kind of signals something in your brain. If it's getting closer and closer and closer and closer, there is what we call an asymptote here. It's just approaching at the end. It's just getting closer and closer and closer. It doesn't approach on this side, and that's okay. Still an asymptote. It just gets closer and closer. And it is a horizontal asymptote. And it is at y equals 0. So just like rational functions had asymptotes, exponential functions also have asymptotes. They only have one, though. They're just going to have a horizontal asymptote. All right. Up next, we have kind of the reverse of this. Y equals 1/2 to the power of x. And so we're going to start with the same value, 0. Anything to the 0 power is equal to 1. And then we're going to press on. So to the first power, 1/2 to the first power, anything to the first power is just equal to itself, right? And then the second power, this would be 1/2 to the power of 2. And there's two ways you can think about this. When you square something, it's 1/2 times 1/2, or you can square the top and square the bottom. Either way is fine. 1/2 times 1/2 is 1 over 4, or you could think about 1 squared is 1, 2 squared is 4. 1/4. All right, going the other direction into the negatives, this would be 1/2 to the negative first. And so what's going to happen here is it would be 1 over 1/2 to the positive first power. And this is 1 divided by a half. Well, how many times does a half go into 1? That is equal to 2. And so what actually happens on your fractions, you can, instead of thinking about them like this every time, you can just flip them over. So the negative second power, that would be 1/2 to the negative second. And so you can think about this as flipping it over. So instead of 1 over 2, it would be 2 over 1. It flips it. And then it raises it to the power of 2. And 2 squared is 4. And so you see it has the same pattern. When we head this direction, it divides by 2 because there's a fraction there. But if you head backwards against it, you would times by 2, working your way up. So this graph is actually going to look very, very similar to the one we just did, but it's going to be the reverse. So -2, 4. -1, 2, 0, 1, 1.5, and then 2 1/4. So this is going to head up this direction, and this one is going to head out, and it's going to get closer and closer and closer to that x-axis, but never actually go across it. When you raise these to higher powers, they're just going to get closer and closer and closer to 0. So once again, we have a horizontal asymptote, and it is still at y equals 0. All right, so if we were in class, I would have not told you a bunch of the similarities, differences as we were graphing these, and we would just talk about them, that they literally have the same numbers, but they're reversed because this is base 2, where this is base 1/2, and that's the reverse of that, right? So we're just going to see some more examples here. All right, 3 to the x. So instead of 2 to the x, we're going 3 to the x. So we're going to do to the power of 0. So 3 to the power of 0 is equal to 1 because anything to the first power equals 1. Or sorry, anything to the 0 power equals 1. All right, the next one is 3 to the power of 1, and 3 to the power of 1 is just 3. And the next one is 3 squared, 3 to the power of 2, and 3 squared is 9. And those shouldn't be too bad. Those should be pretty easy. You just plug in, right? Do the power. You're good to go. They get slightly more complicated when you go into the negative. So this would be 3 to the negative first power, which is 1 over 3. It turns into the fraction, 1/3. If you put in negative 2, this is 3 to the negative second power, which turns into 1 over 3 to the second power, which turns into 1 over 9. If you're okay, now that you kind of see the pattern, to just say, if I put in negative 2, I get 1 over 9, I'm fine with that. You don't have to show all the work. It's not that crazy of a calculation. But if you're not sure, follow it through, right? It would turn into a fraction with a positive exponent, and then go ahead and use that exponent to calculate your new denominator. All right, so 0, 1, 1, 3, 2, 9. So it's a little bit off the graph. That's okay. Oops, can't even see it. And then we have negative 1 and a third, and then negative 2 and a ninth. So here is that exponential. If you compare it to the last one that was similar, you can see that they're both heading kind of that same direction. They have the same general curve. This one is just steeper because this one has a base of 3, where this one only has a base of 2. So this one grows a lot faster than this one grows because of those bases. Just like the other ones, though, this also has a horizontal asymptote. So horizontal asymptote, it's at y equals 0. All right. Next graph is going to be 1/3 to the x. So because this is 1/3 and we just did base 3, you're going to see some similarities here. Anything to the 0 power equals 1. First power would be a third. The second power means you're going to square this, right? And 1/3 squared, you can do 1/3 times 1/3, or 1 squared over 3 squared. And so either way you do it, it will be 1 over 9. When you go into the negatives, you're going to flip your fraction around. So to the negative first power, 1/3 to the negative first power is going to turn into, instead of being a fraction, is going to turn into a whole number, a whole 3 to the first power, so just 3. And when you raise it to the negative second power, it's going to turn into 3 to the second power, which is equal to 9. So 0, 1, 1 and a third, 2 and a ninth, negative 1 and 3, and then negative 2 and 9. And that one's off the graph as well. So here is your curve. There is your exponential graph. And if you notice, it actually is very similar to this, except for this one has been flipped, right? It's just been flipped over. In terms of like this piece is now over here and it's heading this direction. Still has a horizontal asymptote here at y equals 0. They're not always at y equals 0. Depending on if there's any adding and subtracting going on, they might change, they might shift. All right, so here are the 4 graphs that we've made so far. Put them all on there. These 2 were whole numbers, so this was 2 to the x and 3 to the x. This was fractions, 1/2 and 1/3. And so these 2, if you remember, had the same values. They were just flipped around. And these ones also had the same values. They were just flipped around. And so whenever you have whole numbers, your graph is going to be heading this direction. It starts off really small on your graph and it's going to grow. And so we call these 2 graphs exponential growth. So 2 to the x, 3 to the x, that's exponential growth. These 2 graphs, because they started big and as you went on with your x's, they got smaller and smaller and smaller, we call those decaying graphs in terms of they're just kind of decreasing. They're getting smaller values. The values are decaying. They're getting smaller, essentially. So you can refer to these graphs as having exponential growth and exponential decay. And here's how you tell the difference. If your base is greater than 1, it will grow. So if you have a base of 2, 3, 4, 5, even a decimal like 1.3, as long as it's bigger than 1, it will grow. Decay is when your base is less than 1. However, it can't be every number less than 1 because it can't be less than 0. So we're going to write it as an inequality that says B is greater than 0 on this side, but B is also less than 1. So B is stuck between 0 and 1. So that's where you'll see your fractions like 1/2, 1/3, 1/4, 2/3, things like that. Just be aware, it's not fraction versus not fraction. So for example, I'm just going to throw this one out there, 5/4. That is a fraction. So if that was the base of the exponential, we have 5/4 to the power of x, it would not be decay, even though it's a fraction, because it's the value of the fraction. 5/4 is not less than 1. 5/4 is actually bigger than 1. So this would be an exponential growth function. So don't think about it as fraction, not fraction. It's less than 1, bigger than 1, and then remember, negatives aren't allowed. All right. So we have a couple more graphs that have some extra stuff kind of going on here. So we're going to talk about these. So this first one is 1/4 to the power of x plus 1. So let's see what that plus 1 is going to do to our power or our exponential. So I'm still going to start by plugging in 0. So 1/4 to the 0 power, that is equal to, and here I will actually write this out, 1/4 to the 0 power plus 1. So 1/4 to the 0 power is 1, and 1 plus 1 is now 2. Then we'll have 1/4 to the first power, power of 1. 1/4 to the first power is a fourth, and 1/4 plus 1, well, you can think about that as a decimal if you want. That's 1.25, isn't it? And then the last one, this will be 1/4 squared plus 1. Well, 1/4 squared is 1/16, and 1/16 plus 1, I don't know the value of 1/16 off the top of my head, so you can just use a calculator if you want. 1/16 plus 1. So that's 1.0625. And that's the value we get when we plug in 2. It is more helpful to have these in terms of decimals as you go to graph than it is to have them in terms of fractions, because that number as a fraction is 17/16, and you might be able to figure out where that is, but for some of them as a decimal, it's going to be easier to graph. All right, we still have to do -1 and -2. So if you put in -1, this is where things get a little weird, right, because of the negative power. If you put in -1, you're going to have this 1/4 to the negative first. That's going to be equal to just 4. So this will be 4 plus 1, which is 5. And if you look at our pattern, that does make sense that it would get bigger. So I would expect this number to be bigger than 5, this next one. So putting in -2, we would have 1/4 to the negative second power plus 1. 1/4 to the negative second, you would turn that into a 4 to the power of 2. And 4 squared is 16. 16 plus 1 is 17. And so here's your graph. We would have -2, 17. So I'd be like way up here, right? So I'm going to be like, I'm just going to put a dot up there so I have a place to aim. I know it's not even close. It has to be even further away, but that's all right. -1 to the fifth, or -1, 5, 0, 2, 1, and 1.25, and then 2, and that's still bigger than 1. So your graph is going to come down. It's going to hit all these points, and it's going to curve. And the difference here is as it curves, it doesn't curve down towards 0. Instead, it curves towards the line where y is equal to 1. So your horizontal asymptote has now moved. It is now at y equals 1. So anything less than 1 doesn't exist for this graph. And this one has a huge, huge, huge connection to the fact that we added 1 at the end. So what adding 1 is actually doing is it's taking this original graph, 1/4 x, and adding 1 in terms of shifting every single point up on your graph 1. So literally everything shifted up 1, so including your horizontal asymptote that just shifted the entire thing up 1. All right, go ahead and hit pause on the video and see if you can do this next one on your own. Come up with the values. When you're ready, go ahead and hit play, and I will walk you through them. All right, so we're going to calculate these 5. Anything to the 0 power is 1. So this would be 1/4, right, to the 0 power minus 2. So it'd be 1 minus 2, so negative 1. 1/4 to the first power minus 2. That's going to be 0.25 minus 2. And 0.25 minus 2 is negative 1.75. And then the next one, 1/4 to the power of 2 minus 2. That's going to be 1/16. And I'm going to throw that one in my calculator. 1/16 minus 2. So negative 1.9375. And then heading the other direction into the negatives, you'll have 1/4 to the negative first minus 2. Well, 1/4 to the negative first, that's 4. 4 minus 2 is 2. And that makes sense in terms of the direction that my numbers are heading, right? Getting bigger, bigger, bigger. So I'd expect this number to be bigger than 2. So the next one is 1/4 to the negative second minus 2. So that's 16, right? 16 minus 2 is 14. So your graph is going to be negative 214, which is going to be like way up there, right? I know it actually is probably further away, but that's okay, way up there. Negative 1, 2, 0, negative 1, 0.75, and then 0.9375. So your graph should look like this, and then it's going to take off and head this direction. And so where did that asymptote go? Well, it started at 0, and it is now down here at negative 2. And we can see that in the equation in terms of the fact that there is a negative 2 right there. So that number at the end being added or subtracted is affecting your horizontal asymptote. It is either making it go up or down. It doesn't make it go left or right at all because it doesn't make sense to move a horizontal asymptote left and right because it's already running left to right. All right, we have one more that we're going to talk about. One more section, sorry. And this is now what's happening when you have a number in the front. So we're still going to plug in those same numbers, 0, 1, 2, negative 1, negative 2. And we'll see what happens. So plugging in 0 first. So this is 1/2 times 4 to the power of 0. 4 to the power of 0 is 1. 1 times 1/2 is 1/2. Remember, you have to do exponents first based off the order of operations. Up next, 1/2 times 4 to the power of 1. Well, 4 to the power of 1 is 4. 4 times 1/2, what's half of 4? That is 2. 1/2 times 4 squared. 4 squared is 16. What's half of 16? That is 8. All right, going the other direction, 1/2 times 4 to the negative first power. And this one might be a little bit harder to calculate, so let's do this in pieces. So this will be 1/2 still times, what happens with the 1/4? It turns into 1/4, doesn't it? So it's 1/2 times 1/4, and 1/2 times 1/4 is 1/8. Multiply across the top, multiply across the bottom. 1 times 1 is 1. 2 times 4 is 8. All right, and last but not least, 1/2 times 4 to the negative second. So that would be 1/2 times, well, 4 to the negative second is 1/4 squared. So 1/16. Multiply across the top, multiply across the bottom. We'd have 1/32. If you want them as decimals, just type in 1/32 in your calculator, 1/8 in your calculator. So if you need them, here's 1/8, here's 1 over 32. You can write those decimals down as well. What you're really seeing is that they're getting really close to 0, aren't they? All right, so let's plot. So 0, 1/2. 1, 2, 2, 8. And then close to 0, even closer to 0 on that side. So your graph is going to look like this. And there is still a horizontal asymptote. And it is at y equals 0 because there was no plus or minus outside of that to move things up or down. All right, let me see. We graphed 4 to the x, didn't we? No, we didn't. Well, I wish we had. That's a bummer. So what's happened here on your graph, and it might be hard to tell, if we had graphed just 4 to the x, we would have seen that it would grow like this. It would be like, la, 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 shoom, and it goes like almost straight up. It would go up really fast. And so what's happened is it's actually like squished it this way. So now it doesn't go up as fast because there's a 1/2 in the front. It still goes up really fast, but just a little bit slower than if there was, if it was just 4 to the x. All right, I'm going to let you pause the video again. Try this last one on your own, and then we can come back and talk about it. So when you're ready, hit play. All right, if you tried it on your own, you might have realized that the only difference here from the one that we just did is the fact that it's a negative 1/2. So all these calculations are all the same, except that they are now all negatives. Because timesing by 1/2 versus timesing by negative 1/2, it gives the same value, but just a different sign. So these were all the same numbers as we had here. Only difference is they're all negatives. All right. So I'm going to start here. 0, negative 1/2. 1, negative 2. 2, negative 8. So we can see this side headed this direction. And then negative 1 and an 1/8. Or a negative 1/8. And then negative 2. Negative 1 over 32. So this is going to go this direction. And so the only difference between this graph and this graph was the negative in the front. And what happened? Literally, this graph flipped over that horizontal asymptote, and it's the exact same graph, just flipped over. It is still an exponential growth graph because it's still 4 to the x, so it's still growing, but it is in the negatives, and that's okay. We still call it a growth graph, even though it's kind of starting here and then going down. It's growing negatively, if that makes sense. Still have a horizontal asymptote there at y equals 0. That didn't change. And so that negative, all it did was take that graph and flip it over. All right, so a couple examples for you. Hopefully that kind of nice little introduction into some exponentials. In terms of your assignment, you're going to be working in your packet on the next page. It's just the back. So there are 8 for you to do on your own. So there's these 4 here. And you saw examples of those 4. So make yourself a table, throw it on the graph, and label where the asymptote is, right? So it says sketch the graph and determine horizontal asymptote. Over here, these are a little bit different because you didn't see an example of this. So let me kind of walk you through. See how this in the exponent, it says x plus 1? That means you add 1 before you raise it to the power. So for example, if you put in 0 here, you do 0 plus 1 first and get 1, and then 4 to the 1 or 4 to the first power is 4. So your points are going to look different because of the fact that you're adding before you raise it to the power. So just be careful. Just be careful there on those ones, all right? Do the add subtract before you calculate anything. So you're doing what's in the exponent first. All right, you just have to have this done by next Thursday, right? Nope, hold on, wrong week. Yes, next Thursday. So you guys will be back in class on Thursday. Your test is on Monday, and then just take care of the practice by next Thursday. All right? Let me know via email if you have any questions, anything I can help you with, and good luck.